So please don't talk. Yesterday's problem had 4 papers, or what do you know what I mean? Papers had 4 problems on it. All right, let's just grab this one. Or did we already do this one? No? Okay, please do not talk. Anytime you waste is less knowledge you'll have for the exam. That will happen tomorrow no matter where we are. All right, looking here as a review. In Hess's law, we are trying to find the enthalpy of, well, I'm going to call the overall reaction or the wanted reaction, whatever you want to call it. And we're given the enthalpy of 3 reactions that when combined the correct way can give you the overall enthalpy. Ready? So you look and you have solid carbon on the left. You look down here. Do you have solid carbon on the left? Yes, but what's wrong? All right, it is not the right coefficient. So I have to multiply all of this by 2 to make that work. Thumbs up if that makes sense to you. All right, so I must make the 3 given reactions match these things exactly. All right, so I have solid carbon. I'm going to double it. That would put 2 C's, 2 O2s, 2 CO2s. And it would make this around 800, right? Or negative 800. Okay, moving on. I move on to hydrogen. H2 is on the left. And over here, H2 is also on the left. That's good news, right? Is the coefficient the same? Yes. So I don't need to adjust anything on this one. Oops. Yeah, that was right. So that one's just the way it is. I don't have to reverse it. I don't have to half it or double it or triple it. Okay. The next thing I need to look at is acetylene. C2H2 is a product, but over here, it is a reactant. So what do I need to do? All right, I need to flip this one around, or I need to make this a positive. Are we all right with that? Okay, then we sum everything up. 798. Anyone else have that? Oh boy. What's our rule in this class? In the calculator of 2 or 3 nerds shall every number be established. So what is it? Maybe 2 something? 226? Good enough for me. All right. The hardest part of these problems, honestly, making sure you type them into your calculator right. Because sometimes you're going to add a negative. And that's fine. Adding a negative just means subtract or put your negative in parentheses. Okay. Now, something's different today. What happened to you? Apparently. All right. If we like put a house on top of you and your hands came out, that would look perfect. It'd be, what's her face? No, she wasn't. She died in water. You guys don't know what I'm talking about. Don't worry about it. The Wizard of Oz. But the green one is not the one the house lands on, though. That was my bad. But you know what I meant. Okay. Now, my friends, we can spend time making sure things cancel out, but I'm not going to worry a ton about it. Now, I will put these all online. I said I would yesterday, but then kids are killing me right now. Even when she's teaching, kids are coming in for help. I'm like, oh, did I seem frustrated during B time? Just a little. No, I'm not. Were you happy during B time? It sucks. I was driving this morning. Yeah. Why? Just kidding. Yeah. Okay. So anyway, BB came in and asked a question. I'll post it, but I realized what we had to do on that one. It was this one, right? Yeah. This one's tricky. I'm not going to go through every single detail. I have it on my iPad because I did it. By the way, one of them you have to divide in half in a problem. Is that okay? Yeah, if you can multiply, you can certainly divide. All right. This one, you have to reverse and divide one of them. So if I have this right, this becomes a plus. This becomes a half. And this becomes a negative half. I'll put it on the group me so you can look at it. Okay. I want you to do one more problem. This one's above average difficulty. So I don't want to spend a ton of time on it because we don't have a ton of time. Will you try this problem? So calculate delta H for it. And then this says 1, but really it'd be like B. I don't know. I don't think this one was on your paper. Right? Yep. You can just, you don't even need to write it out. You can just look up there. This one should not be real hard, I hope. Okay, I'm going to pause. I'm going to give you 3 minutes. All right, so in the overall reaction, silicon tetrahydride, bet you haven't heard that for a while. Naming these things. Silicon tetrahydride is a reactant, but over here it is a what? It's a product. So this needs to become a negative. The coefficients match? Yeah, they do. Okay. O2, I'm not going to worry about that yet. If I have to, I will, but I'm not going to right now. SiO2 is a product. Up here, is it a product? Yes. Is the coefficient the same? Yes. So that stays the same. Yes. You need to compare all of them. What? Don't do O2. Only do it if you have to. Yeah, because O2 typically, look, and maybe I probably didn't say this, but first off, there's a fraction of wood in front of O2. I don't want to do fractions. No one does. And there's O2 in 2 of these, right? So go somewhere where there's only one thing of it, and usually that will fix the other parts for you. Okay, so look for the non-oxygens, look for the non-waters, and if that doesn't fix it, then go water and go oxygen last. Because oxygen, it's usually everywhere. Okay, so SiO2, you okay with that? It's a 1, it's a 1, it's in the right spot. I'm okay. Okay, next, I'm going to still ignore oxygen. I'm going to look at water. Why do I look at water instead of oxygen? It's in only one place. So I don't have to think, all right, the O's, I need to make sure I have a half, I'm going to have to double or whatever. I don't want to do that. I just look at water because look, O, see how it was a fraction? But what do I have to do here? I have to double this one, right? So the fraction takes care of itself. Could you have done it through oxygen? Absolutely. You can do oxygen, but I would save it to the end and only do it if you have to. Okay, so H2 was a product. It is a product, but we needed a 2 in front of it. So this would be times 2. Good. But you had a wrong number? Or did you have 13, Aisley? Okay, yeah, just skip oxygen, only do it if you have to, because everything else usually fixes it. You would have something else wouldn't balance yet. And 99.9 almost forever, it will be fixed already. There was a problem in the practice where you had to reverse one to cancel oxygen. You remember that one? It wasn't in the product or reactants. So you had to flip it to get rid of it. But okay. Did this end up being negative 13 something? Okay. If you haven't got that yet, have your lab partner watch you type it into your calculator and have them tell you what you're doing wrong. Is anyone in that scenario? Okay, then I'm good. Okay, part B, did you see it? What would delta H for the reverse reaction be? This is going to be worth the same amount of points tomorrow. You just switch the sign. That's what we were doing up here the whole time. If we flipped it, we flipped it.
If we get the first one wrong, the second one right, will you still go to the second one?
Yeah. And I did that on your last test. Like my TA was helping me. She's like, that's not right. I'm like, well, it's right with the wrong number. Her percent yield. Someone, I can't remember who it was. Could be a boy, but one of you had the wrong answer for percent yield, but you had the wrong grams, but your percent yield calculation was perfect. By the way, I should tell everybody, percent yield and percent error are different. Did I already say that? They are different. Percent yield is what percent did you get on your test? Percent error is how much percent were you wrong? So 1 is O minus A divided by A. That's your percent error. The other one is how much did you get, which is just what you got divided by what you should have got. Because tons of people did that wrong. And I want you to like be my friends here for a second. Think sometimes. I'm not trying to be rude. I was rude third out or whatever. You still love me? Okay. I don't remember. Let me look. Because I don't remember which scenario it was. But you should have been able to realize, hey, my math is wrong. Because, and I don't remember which way it was, but in your grams, you got more than you should have, if I remember right. Is that right? So your percent should have been above 100, and most of you put it was 82. But think about it, you can't have more but have less than 100%. Am I making sense to anyone? Okay. Yeah, like if you got 12 out of 10 on your test, you got extra credit, right? So you got above 100%. You got 120%. But you guys were saying, oh, I got 12 out of 10 on my test. I'm sorry. I still love all of you though. Okay, moving on. I feel okay about this. Are you okay with the Hess's law question? That looks a lot like this problem. Okay. I will note. Okay. If anyone needs more Hess's law help, that takes you to Khan Academy. It has a video, it has practice, and it has a quiz if you want. I don't know. The Khan Academy, it doesn't usually do this, but like the intro video is like 5 minutes. The practice video is like 20. You're like, spit it out, Sal. Like, it's not that hard. But if you need more help, you can scan that, watch it, and enjoy your evening. Okay, next. Enthalpies of formation. This will sound more difficult than it is. I handed this out. It starts here, I believe. Nope, it starts here, right? Yes. I know it's real small. I thought small text, but more info would be better. Are you okay with that? All right, here we go. This is not any worse than anything we've done yet. And hopefully you realize chapter 5 is a lot easier than chapter 3 and 4. Here we go. The standard enthalpy of formation is a measure of the energy released or consumed when 1 mole of a substance is created under standard conditions from its pure elements. The symbol of the standard enthalpy of formation is delta H naught and a little f. And then there's a period at the end of that sentence. That's not part of it. So delta H naught with a little f. I wondered how I had so many extras. There we go. All right, make sure you have that paper. So raise your hands if you don't have one. Okay. All right, this is the first one of these all year. And they used to like intimidate the crap out of me because I'm not a math guy. Most of you are smarter, like way smarter at math than I ever have been or ever will be, but they're actually pretty easy. but let's break it down. So delta means a change in enthalpy. There should be an H. Come on, Tom, you had one job. Delta H means a change in enthalpy. We're okay with that. This little thing that looks like a degree sign, because it is, it's also called a knot. So it's delta H knot of formation. I have no idea. I think it's a K, but I really don't. Or NAUGHT. I think it's that one. All right. And what it means, it just means that it's standard. It means it's happening at room temperature and room pressure and 1 mole of stuff. And you don't have to know that, like that definition, but it just means like under normal conditions, this is what happens. All right. The F indicates that the substance is formed from its elements. That was close. Elements. Because there's a few delta H knots with different letters. This is one of them. It just means we're making something like carbon dioxide out of its C's and O's and the energy required to do that. That's all we're saying. Okay. The equation for this is obtained from yada, yada, yada. Who cares? It is this. Delta H naught of the reaction, and that's kind of dumb because I just cut it from the internet, but it would be fusion as well. But it doesn't really matter, is the sum of the products minus the sum of the reactants. Okay, this right here means sum. It means that you're going to add a bunch of stuff, and then you're going to subtract it to a bunch of stuff. And that would be your answer. Sum means add, then you subtract. Well, you add, and subtract. And it always has to be the products minus the reactants because delta means final minus initial. Are we okay with this so far? It looks uglier and harder than it really is. So here we go. Let's just look at this example. So given a simple chemical equation with the variables A, B, and C representing different compounds, and you'll always have to have these. These will always be given to you in a table. I don't like that one, but whatever, right here. These have to be given to you. You never, ever, ever have to memorize them. So here we go. We want to find delta H. That's what we want to know. So delta H for this reaction is equal to some question mark. So there is only one product, correct? So it is sum of the products minus sum of reactants. So I look up here, the product is C. You with me? Okay, so C is 523. And I'm going to subtract the sum of the other two, which are the reactants. A is 433 plus negative 256. Now, if you feel like it, you're like plus a negative, that's dumb. That's just minus. That's fine. I don't care. But be careful. Does anyone remember a long time ago I said in this chapter, you need to be a good accountant? This is the problem when you get to accounting. All right, you got to make sure like, oh, I'm adding a negative, well, I'm really subtracting or whatever. Okay, so math-wise, you do this plus this, and then you subtract that from 525. You got it for me? 356, 346. Say we're talking about accounting. It sucks. 346, positive or negative? Positive. That's not awful, is it? That's it. Now, hold on. I love the smile. There's a but it's this one's not a but. Just, yeah, that was awkward. Just look right here. This is, remember, you need to be a good accountant. If, let's pretend there was 2A, you do have to make sure that you double A. That's the only if. So you would have 2 times that plus whatever. So make sure you distribute the coefficient. That's the only extra part here. Okay, thumbs up. Okay, here we go. So NO2 is formed from the combination of NO and O2 in the following reaction. Find delta H from, or use the formulas for standard to be changed, formation, whatever. And here are the things that you need. So we want delta H for this reaction right here. And we have this information. Are we ready? So sum of products minus sum reactants. So now I have a question. Why would oxygen be 0? Because it's an element already. This delta HF naught is the energy required to form something out of its elements. Well, if it's already an element, does it take energy to make it? No, oxygen was created a long time ago. So it's a 0. Okay, here we go. So I have 2 times whatever NO2 is, right? So I come down here and it is 33.18. Tell your partner why I doubled this one. Because the coefficient. Because the coefficient. All right. Then I'm going to subtract the products. I have 2 times NO, which is 90.25. Now you don't have to do this, but I'm going to put plus 0 specifically. Just for what? Yeah, I would at the start. So you remember, I incorporated all that. Sum of the products minus the sum of all the reactants. Math-wise, 180.5, right? 66.38. Okay, whatever. And then just subtract whatever that, or sorry, subtract this from that. Negative 114. Okay, you could probably like, oh, I get why he was confused. 114 or 0.14. Yes, sir.
Is the answer kilojoules or kilojoules per mole?
Just kilojoule. It doesn't matter on this one. Yeah, technically this would be per 2 joule or 2 moles of that, 1 mole of that, and 2 of that. So probably just write kilojoules. Okay. So far, okay? Let's do another one. Now, these are the most common that you'll see on tests. They're combustions, and they require good accounting. It's the exact same thing, just a lot of 6s. This is the equation that proves that sugar's from the devil. What? You tell me. Guess how much sugar I've had. Okay, how are we doing? Did you say I have no clue? Did you say I have no clue? Oh, I was like, oh no. Your hands are so distracting. All right. So I have no idea. What do we have? 28 what? All right, my friends, who had a negative value? Would that make sense? Sugar? Sugar. Yep. Why? Because when I eat sugar, it gives me energy. Can you back that up? I was watching Mankind last night because why not? And it was like humans' DNA is set up to like desire sweetness above all else. Well, what's sweet? Sugar. Why does our body want it above all else? We want energy. And per size, it's one of the greatest forms of energy we can take in. It's super easy to break down, super easy to store right here and right here. And it gives off a ton of energy, way more than we'll use. Yes. Then you got math problems. All right. One more. Let's actually. Is this one? This one's probably not on your sheet, right? Let's try this one while we're together. Not on your sheet. Not on your sheet. Might see it again. Who's ever heard of the thermite reaction? That's this reaction. Oh, I didn't include the paragraph at the top. Hold on. Ow. Well, you can kind of figure it out right down here. If 30 grams of aluminum were added to iron 3 oxide, so sorry about that. It should have been right up here. Okay, stupid. I get you. So Al plus FeO. Now it's not. What's the charge of iron? 3. What's the charge of oxygen? Fe2O3. What is the only option we can do here? A single replacement. Awesome job. Where aluminum is now with who? Oxygen. And who's left out? Iron. But remember, iron wants to be alone, right? So it was able to oxidize aluminum. Remember that stuff? I know that was forever ago, like a week. Okay, there you go. It's not balanced. You balance it. You go. Hey. Oh, yeah, I didn't record that moment, but I didn't record any of that moment. But here's your answer, and get over it if you should have been in class. Okay, which element is reduced? Reduced means it did what? Gained electrons. So which one went from a positive to a 0? Iron. And then, oh, look at that. If 30 grams of aluminum were added to excess iron 3, why is it a stupid question?
Because the excess is the iron 3. It says that.
It tells you. I'm trying to be nice. All right. Okay, here we go. How many joules of heat would be released or absorbed if 15 grams of Al completely reacted with iron 3 oxide? So how would you do that? Yep.
Wait, what?
That's the value we just found. We're going to use. Okay, so what's the given here? Like, hopefully we've learned this process. 15 grams. So what must come down here? Grams of Al. We okay with that? So I guess I got to be careful how I answer that question. It's per whatever the coefficient was. You'll see. You'll see what I mean. Okay, so how many grams are there in aluminum? Okay, I'm going to say 27 grams per every what? 1 mole of Al. Okay, do I have a relationship between joules and moles? Yeah, look up here. And I answered Preston sort of incorrectly. This is our answer, but for Al, what was the moles? 2. So for every 2 moles of Al, whoops, I don't know why I did that right there. We had 747.
Wait, does it matter if it's negative?
Well, it says would be released or absorbed. So when we write our answer, you should write released or absorbed.
Okay.
So which one will it be? Released. How do we know it's released? Because that was a negative right there, right? Thermite is an extremely exothermic reaction. So it's one of the most exothermic reactions. Did you? All right, what did we end up with here? Say that louder, Jackson, only.
That's a big.
207677, good enough for me. Almost everyone nodded their heads, so you wrong. All right. Now, letter F. If the reaction in part D were to take place in 5,000 milliliters of water, that's a lot of water on purpose because this will produce a lot of heat. All right, that is already at 20 degrees Celsius. What would be the temperature of the solution after the reaction had gone to completion? All right, assume the solution has the same specific heat as pure water. So we have Q equals SM delta T, correct? What are we solving for in this problem? Delta T. It's just algebra. So delta T is Q over SM. Is everyone okay with the math right there I just did? All right, so I'm going to bring it over here. Q, we just found, was 207677. S is 4.184. And M was, you gotta be sort of careful. $5,015. Now that's not super accurate because there would have been iron oxide as well, but those are the 2 total grams I gave you. So 5,015. Here's the good news. If you forget the 15 tomorrow, it's not really going to matter because 15 out of 5,000, the way we're going to round, not significant. Okay, what does that equal? What? What'd I do?
They're just confused about the part
How are
D.
you supposed to do the one?
Oh, I did, huh? It's okay. It's the same process. I apologize. This letter is just incorrect. It should say part E. That's why there's some confusion. I apologize. Math-wise, are we good? You take the heat that was produced, you set it up, and Stacy says it's 9 point something. Okay, now my friends, is that the answer? No, be careful. You have to add that to what it already was. So what was it before? 20. So the answer is 29.89 degrees. Okay, there are other practice problems on the chapter 5 presentation thing you can work through. Hopefully, my plan is to put the answers online again. Well, not again because I didn't last time either. And then let's talk. Yes, Seth.
So this is not negative, but it's released.
It is negative. I ignore it, and then I just know, hey, the whole thing was exothermic, so the temperature has to go up. Okay.
Also,
Yep.
where did 15 come from again?
Okay, Seth asked really good questions. He said, Where'd this 15 come from? It came from the grams of aluminum I put in there. Now, technically, there would have been iron too. I just never typed out how much iron we put in. So for the information you have, just go with it. But hey, and once I said this a second ago, but if you accidentally forget on this one and put 5,000, someone type that in.
It's 9.9.
9.9. So we were 100th off. You'll be fine if you forget that tomorrow. You shouldn't. Okay, I'm not quite done. I know you packed up. Oh, maybe I am done. Oh, I know why. It's this way. Okay, the test tomorrow has 3 multiple choice questions. We've worked through all 3 of them at some point. 2 of them today. All right, 1 of them yesterday. This one is just like it. Like, besides the problem, how do you know potassium nitrate will dissolve? Does that sound familiar to you?
Yes.
Good, because we did this problem yesterday. Now, she always teaches right after, and then I've been driving, I've been busy, so I haven't posted videos very well, but they will all 3, the last 2 days and today, be online. You have these practice sheets. You've seen every question. The numbers will change. The numbers will change. So don't memorize -13 whatever. Memorize that Columbus almost came to America in 1429. Okay, then these are just other practice problems. If you watch this video, you're certainly welcome to practice them. They can help. There are like 5 or 6 multiple choice. At least 4 we've answered in class on that screen. Okay. Any questions? Okay, I feel like I did a pretty fast. I don't know. I feel like I'm going to end this first.